In this mini lecture, I'm going to talk about complex numbers, what they are, what they're used for. We've said before that radicals like the square root of negative 25 are not real numbers. That's because the square root, I have to have something times itself that equals the inside. And something times itself equaling a negative is a problem because positive times positive is positive and negative times negative is also positive. So to get a negative, I have to have a positive number times a negative number, and those aren't equal. So in this section, we're going to explore this topic more, introduce a new type of number that allows us to handle this situation. Amazingly, it turns out that these new numbers are essential for understanding applications like the behavior of electric circuits. Those would be covered in a differential equations class or something like that. So although it may seem to you that these are sort of strange numbers, in fact the name associated with this, we have the imaginary unit or imaginary numbers. That makes it a little bit problematic for students, but there are many applications that wouldn't exist and problems we couldn't solve if we didn't have this idea. So we start by defining something called the imaginary unit, and we use the letter I to represent this. And this is defined as a unique number. There's only one number like this, such that I squared equals negative 1. So I said I couldn't think of a number that times itself would be a negative, but I say, well, whatever that number is, I'm going to call it I. So that lets me rewrite square roots of negative numbers. So instead of negative 25, I can say that's negative 1 times 25, but then instead of negative 1, I can replace it with I squared. And then the square root of I squared is just I. And so we say the square root of negative 25 is just 5i. So essentially the square root of 25 is still 5, it's just when I have a square root of a negative, an I gets tagged onto it. So this allows me to form a new set of numbers called the complex numbers. So if I have a plus bi, so the a and the b are real numbers. So a could be 2, b could be negative 3 or whatever. I squared is this negative 1 this special unit. That's called the set of complex numbers. A is called the real part, and the b or the bi is called the imaginary part. So these are examples of complex numbers. 3 minus 6i would be a complex number. 5i, that doesn't have a real part. This is a pure imaginary number, but it could be thought of as 0 plus 5i. And then negative 7 is a real number, a pure real number, no imaginary part, but I could say it's negative 7 plus 0i. So in that way, all numbers we've ever dealt with before are really complex numbers, just with an imaginary part equal to 0. And we say a complex number is said to be simplified if it's written in this form a plus bi. So the real part and the imaginary part are separate. Also, just as a note, if I have an I times a radical, if I have something like the square root of 7i, it's sometimes unclear where that square root line ends. So usually, just to be really clear about that, we stick the I in front of the square root instead of behind the square root, because then it's obvious that I is not part of that square root. So to start with here, let's just write these in a plus bi form. What I essentially do with this is I say this is just negative 1 times 81. So that's I squared times 81. But then that would just be I times 9 or 9i. Same sort of thing here. Negative 1 times 44. So that would be the square root of I squared times 44, which would be I times the square root of 44. The only difference here is the square root of 44 can be broken down more. Remember, with square roots, I don't know what the square root of 44 is exactly, but I can say, is there a number that goes into 44 where I can take a square root? And of course 4 does. So I could say this is I times the square root of 4 times the square root of 11. 2 square root of 11. Usually people would write the 2 first, so the preferred form would be 2i times the square root of 11. All right. With all of these, you could essentially skip a couple of these steps if you just realize the square root of a negative just gives you I, and then we take the square root of whatever's left. So we could skip down here, and we could skip down here. if you wanted to. You wouldn't have to write those steps. They're always going to work the same way. Now, when we have these complex numbers, we can add, subtract, multiply, and divide complex numbers. So to start with, if I'm just adding, subtracting, or multiplying, we just use properties of algebra, like combining like terms, or distributing, or using FOIL. However, we have this special property that I squared equals -1. What that really means is anytime you see I squared, you want to replace it with -1. But otherwise, I deal with these kinds of problems the same way we would have done before. Now, if I'm just adding or subtracting, like we've got here, remember they're really little, unless something else is there, there's really little ones in front. And then that gets distributed. Now, if I'm distributing a positive one, that doesn't do very much. But if I'm distributing a -1, that affects the values. So the first couple parentheses here just drop off. Nothing really happens. But this last parentheses, -1 times -3 becomes +3. -1 times +2 becomes -2. And now I need to combine the real parts and the imaginary parts. So the real parts, I get 2 plus 4 is 6. 6 plus 3 is 9. The imaginary parts, +3i minus 5i, so that gives me -2i, and another -2i would be -4i. Okay, part B, this is just a distributing problem. So I just go ahead and distribute. -3i times 4, just treat I as if it were a variable. In fact, that's what I was doing here in part A, right? So treat I as a variable. So -3i times 4 is -12i. -3 times -2 is +6. I times I is I squared. But here's the little tricky part we have to remember. Anytime you have I squared, you replace it with -1. That's the special thing about I. I itself isn't that special, but I squared is. Usually we put the real part first. So I'd write it -6 plus 12i. Okay, down here in part C, we're going to do FOIL. So first, outer, inner, last. So 3 times -2 is -6. That's first. Outer, 3 times +5i, so that's +15i. Inner, -4i times -2, negative times negative is +8i. And then last, -4i times +5i, negative times positive is -20, I times I is I squared. And what I'm going to do here is I'm going to combine those like terms, and I also have to remember to get rid of that I squared. So -6 plus 15 plus 8, that gives me plus 23i. Then I'm going to get minus 20, but the I squared gets replaced with -1. So -6 plus 23i plus 20. Now I put the -6 and the positive 20 together. So we get 14 plus 23i. And finally, part D here is just to remind you there's no shortcut here. If I have a quantity squared, you have to write the quantity out twice and then do FOIL. So the FOIL's not too tricky here. First, outer, inner, last, right? And we just get that stuff. We combine together. 6i plus 6i is 12i. The I squared becomes -1. And then 4 minus 9 is -5. Okay, and finally, what about dividing complex numbers? When dividing complex numbers, we're going to make use of this idea of the conjugate, the same that we did when we had to rationalize the denominator when I had radicals involved. So remember this idea of the conjugate. The two parts of the binomial stay the same, it's just that the middle sign changes. So 2 plus 5i would just become 2 minus 5i. Negative 9 minus 7i, the negative 9 stays the same, but the 7i changes from negative to positive. So we make use of the conjugate here. We multiply by the conjugate of the denominator. So I'm going to multiply the denominator by 4 plus 3i. The numerator then also gets multiplied by 4 plus 3i. In the numerator, if I just have a single number in the top to begin with, I'm not going to get too quick to distribute because it's possible at the end I'm going to be able to cancel out something. I do FOIL in the bottom. 4 times 4 is 16. Remember the idea of the conjugate. When I do outer and inner, they cancel out. Now, if you want to write them down, you can. I get plus 12i and minus 12i from outer and inner, but those cancel out. And then I'm going to get minus 9i squared. It's just difference of squares. 4 squared is 16. 3i squared is 9i squared. So I get 75 times 4 plus 3i over 16 minus 9, times negative 1. So I end up getting 25 in the bottom, and of course then I can cancel. 25 goes into itself once, goes into 75 3 times, and now I can distribute. 3 times 4 is 12, 3 times positive 3i is plus 9i, and it would all be over 1, but that just goes away. So that would be my result. And my last example here, I again use the conjugate. So negative 3 stays the same, but the negative changes to plus 2i, and I do the same thing in the top. Now, here, when I've got a binomial in the top and the bottom, I really need to do FOIL in both places. So 2 times negative 3 is negative 6, and the numerator, there's no predicting. It's not going to drop out here. 2 times positive 2i is positive 4i. 5i times negative 3 is negative 15i. See, they don't drop out. 5i times positive 2i is positive 10i squared. Now the bottom should be nice. Negative 3 times negative 3 is 9. Negative 3 times positive 2i, that gives me negative 6i. Negative 2i times negative 3 is positive 6i. Those drop out. Negative 2 times positive 2 gives me negative 4i squared. So remember, we can combine like terms. Plus 4 minus 15, that gives me negative 11i. And the I squared gets replaced with negative 1. See, this isn't really that bad. Same thing here in the bottom. So, negative 6 minus 11i minus 10, all over 9 plus 4. So negative plus negative gives me even more negative. And now here's just the one tricky part. It says write in a plus bi form. That means the real part and the imaginary part should be separated. But they're not separated here. They're all in one common fraction. It's really easy to fix. I just split it apart as 2 fractions with a common denominator. And we usually then, if there's a negative in front, we bring it down, a negative in the top, we bring it down in front. And we usually write the I just after. It's really I over 1, so we would write it in this form. That's the most common form it's written in. And that's how complex numbers work.